Hey everyone. Okay, so this is a tutorial associated with Lab 3. So the purpose of Lab 3 in this tutorial is to get a little bit more practice with Model Builder, especially the iterator option in Model Builder, which can be super useful when you've got lots of different files and you want to do the same process for lots of different files. Sort of similar to what you were doing with creating all of those different buffers in Lab 2. If you already had a bunch of different buffer files and you just wanted to cycle through them all, then iterators are really nice. And then we're also going to just go through a couple of other kind of fun tools that might be useful with points and with lines. And these data are bare radio collar data collected by an environmental conservation graduate student a number of years ago. And so you should have a folder that looks like this over here, where you've got 4 shapefiles associated with some geography in Newfoundland, including just the borders of the island, and then rivers, streams, and water bodies. And then you should also have a folder that has a bunch of bare collar data in it. So before we get started, especially when you've got table data, tabular data, you always want to take a look at it. So don't want to start anything before you know a little bit about your data. So we know that this is some XY data associated with this bear, blah, blah, blah. And what we're looking for in here, just like we have before, anytime we're doing an XY table, is some geographic information. And if we go over here, I can see that there is an X and a Y. So I found an XY. Those look like geographic coordinates, right? The first thing that you should notice in looking at these is that those are not decimal degrees, right? They're way bigger in the x-axis than -180 to 180 that a decimal degree would be, and way bigger in the y direction than -90 to 90 would be. So this tells you, because those are not decimal degrees, this cannot be a geographic coordinate system. Anytime you're dealing with trying to display data that are not a geographic coordinate system, you should never be guessing, right? This is not a time to guess. There are so many different projections out there that you want to be certain of what it is. So I've told you in the metadata, or the lab report assignment, whatever it is, metadata for this lab, that for these particular data, these bare coordinates are in the same coordinate system, the same projection as all of our shape files. And so let's just take a quick look at what the coordinate system is for these guys. And it is a UTM projection. If you guys don't remember, that's where you have, so universal transverse Mercator. Mercator is basically the cylinder. Transverse just means it's a cylinder on the side. So a cylinder on the side, what that does is you have the least distortion along a line of longitude. In this case, the one associated with zone 21, which we could, maybe it tells us down here, is at -57 westing, basically, is where that line of longitude is. Okay, so we've got the nice thing then about doing any kind of display XY for these is that because it's the same coordinate system, the same projection as all of our shape files, it should be pretty easy to find that option because it should be the same as what our map is. We can double check that too. Remember that the so UTM zone 21N, which is associated with these shape files down below. Evidently, we've got some other coordinate systems going on too, but at least Newfoundland and the water bodies are in this zone 21 north, so we're in good shape because our data frame has assumed that coordinate system. So the topography data that is the background information is in geographic, and I don't even know what this is. Let's just avoid it for now. It's probably the same, just labeled something different. Okay, so we have confirmed that we're going for this UTM zone 21 north. And before we jump into Model Builder, I like to do, or at least get started on the workflow by itself so that I don't have to guess, that I can troubleshoot, make sure that this works just fine before I jump into Model Builder. So here's where this is important. GIS has suggested a geographic coordinate system with units of latitude, longitude. You know that those are not a geographic coordinate system. And so let's go with the projection of the current map, which is that UTM zone 21 north. It would be the same if you chose Newfoundland because that's the coordinate system of Newfoundland too. All right, and what we want to have happen here is that our points show up in Newfoundland, right? They show up someplace else in the world, then something's going wonky here. All right, points in Newfoundland, always a good sign. Okay, so all of this seems to be sort of progressing as we would hope and expect. And so let us, rather than, I'm just going to remove that because I've verified that it's going okay. I'll leave that in there for now. Now let's do that same process, but in a Model Builder iterator. So go find your Model Builder. In Arc Desktop, it should be just across the front with this little symbol. And in Arc Pro, you have to go to the Analysis tab first. So here I have a new model. In Arc Desktop, there's a drop down to insert things. So that's where you find all of this stuff. In Arc Pro, here it is right here. What kind of iterator do we want? So an iterator basically says, go through all of these different, what are they? Are they shape files? Are they raster layers? Are they tables? I like files if I'm starting from a bunch of tables because that's generic enough that it usually recognizes anything. Okay, so just like we've done before, double click on that. And now we can browse to see what folder all these data are contained in. In order to iterate through something, they need to be in a folder. They could be in a folder that has a bunch of subfolders. That's okay, but it's easiest if they're all by themselves in a single folder. These are all the things that you want to iterate through. So let us find our, so what you want to do now is to go and figure out your path to your folder that's over here. Mine is a little bit unwieldy, but I will get there eventually. Wait, back up. Practice data, that's where I want to be, not the Pumas yet, that's for later. So here's my folder, my bears folder. A wildcard is basically, I can hover over the little identify. Basically, if you had lots of different files in your folder and you only wanted to operate on the ones that started with MR, you could put MR star, and the star indicates everything start MR and then whatever after that is totally fine. So if you just wanted to operate on the MRs and not the ABs or anything else, then you could put that in there. In this case, because I just want to open our bears again, there's nothing else in here except the bears, so I don't need a wildcard. Similarly, file type. If you just wanted to operate on the CSVs and not the shape files or whatever that was in this folder, then you could say CSV. There's one important thing associated with this, which is that they say don't put a dot, don't put a period before it. So you would just say CSV. That's fine, I can leave it or not leave it. I'm just going to delete it because everything in that folder is what I want it to be. All right, so we have now told the iterator, look in this file, look in this folder. But the iterator isn't actually going to look in that folder and find what's in there unless we run this thing. So I'm just going to real quickly run it. And now when I hover over this, for example, oops, why is that not? Now it should have a live file, basically. Apparently it looked at the schema folder, so maybe I will put that CSV in there. run that again. Don't look at any schema files. So now it's saying, okay, the last file that it just iterated through is this mr0817.csv, right? Because it started at the beginning and went to the end. And you'll notice that when you look over, hover over the name piece, that also says mr0817. This is a nice feature of an iterator because basically it says every time it's going to start with this first file, do whatever you tell it to do after that, then move on to the next file. But while it's working on this first file, it's going to remember the name of that as the name. So that's going to be useful in just a second. Okay, so let's do our display XY. XY table to point is the name of it in Arc Pro and probably in the other one too. And I can now drag my table over and make this the input table. So I want to make sure that my X field is X, that my Y field is Y, just like we did before. I also want to make sure that this is correctly assigned to that UTM coordinate system. Okay, so this is going to output this feature, right? So here's where the name comes in handy, right? Because I don't want to just like be re-exporting the same file on top of each other. I also don't want it to be like temp1, temp2, temp3, something like that. So if, and this is the scripting in GIS, you use a %, and then it has to be capital name, because that's what this is called over here, capital N name, and then I'll call this points. So basically what this is going to do is every time it loops through, it's going to say, what's the name of this one? Oh, it's MR0817. And so it's going to call this MR0817 points. All right. And this is outputting to my project geodatabase. So let's go ahead and run this, and then I will see if I can actually find my project geodatabase. Oops. To check it again, it was only operating on that single one. I want it to actually run through all of them. The iterators, so this is just as an FYI, when I've run this through the Puma data, it kept giving me random errors like GIS crashed kind of errors. And I just had to keep pressing go a couple of times, you know, like on the second time or on the third time, it would go through the whole thing. The other piece is that if you've already iterated through so that you're like at the last file, then that's where the iterator is going to remember unless you click that validate and start it afresh from the beginning. All right, it is working on trying to see which one it's okay. So it's on 0817 right now, which should be down at the end and almost done. Okay. Can click the close on completion and then I'll know for sure that it's done. Okay, so when I refresh this, hopefully there will be some more files in here, right? So there's my 0802, 0806, 0807, etc. down here. If I want to look at each of these, I can bring any of these guys or all of them in and see them in the different locations. Hopefully all, can I select all of these? I think I can just grab them all, bring them in. Hopefully everything in Newfoundland, right? Okay, so that's good. So pretty quickly with our model builder iterator, I'm going to click validate again so I don't make that mistake again. We have now taken these however many files there were, 9 or something, 10 or something, and quickly created the equivalent number of shape files for those. All right, so that's good. That is an introduction to iterator. Okay, so a next thing that we might want to do is we have a bunch of these sort of bare point locations of where they were at any given day. We didn't actually pay too much of attention to like how frequent these bear dates were. Okay, so we have a date and a time. Those are a little hard because they're not integer numbers. But okay, this is much nicer. So the day here is a Julian day, which basically means that January 1st is 1 and December 31st is 365. So this is somewhere in October or something like that. So we've got a year and a day, which is nice information on how our animals are moving around. Great. And in many of these cases, we've got multiple points on any given day. So one thing that we might want to ask about bears is, what is their home range? What does their home range look like? How far have they moved on this, however long they were collared for? So there is a tool for that, and it is called bounding geometry, minimum bounding geometry, in fact. So what this tool does, and I can drag that guy over, oops, get over there, input features. So my input features again is whatever we just came from, nicely is still called %name, %points. I'm going to call my output features also %name, except I'm going to call this convex hull. Because a convex hull, so there's a bunch of different options in terms of how you want to draw this is going to draw a polygon shape around all of these points. So it could be a rectangle that circumscribes all of them. It could be a circle that goes around all of them. A convex hull is basically like connecting all of the points around the outside. You can play around with these depending on what your desire is as far as an output. And the group option is basically if you wanted a bunch of convex hulls or a bunch of bounding rectangles, if that's what you chose to do, you could also group it by, keep the bear data from 2018 separate from the bear data from 2019, because I want to compare how far it traveled or whatever between those two seasons. So I could do that based on, let's see, a list, and then I should be able to put year in here, year, if I wanted to, but actually I don't want to, so I'm just going to get rid of those. But you could play around with that and see what happens if you group by different options in there. You just get different shapes. Maybe all is the way to go. Okay, so that just finished, although it did crap out on me once, and I had to restart it from where it left off. But and if that does happen, you can just press run again if you get an error that basically is not an understandable error and is happening somewhere in the middle of the different processes. Just try pressing run again and see if it'll finish through everything. Okay, so back over to our geo database. Let me refresh that guy, and now I should have a bunch of polygons in here with the convex hull. So let me bring the points in just so that we can have a look at those. And then a convex hull looks like this. So it's basically a polygon outside the bounds of these. If it were a rectangle, it would look something like that, around the outside. So a convex hull is kind of nice because if you want a quick estimate, kind of quick and dirty in this case, because there's probably some excess area that we don't really want to count, but at least a quick and dirty estimate of range or area encompassed by your points, then this is a good way to do it. And I should already have that. That's going to be in units of square meters, but let's see, 3 divided by 1,000,000. I don't know, 1,000 square kilometers is a pretty good home range for an animal, right? Lots of area covered. Okay, so that's one tool that might be useful. Another tool is, let's say we not only want to know, how the area where the bear has moved, but maybe we want to know actually how far it's moving on a day-to-day basis or on a total basis. There's a tool for that too, which is actually kind of intuitively named point to line. Points to line. Okay, so we need to make sure that it's our points going into our points to line. You can't do polygons to line. Points to line is kind of a fun tool in that there are some different options in here in terms of both the a line field, not so much the sort field, but definitely the line field. So let's start by naming this as our same percent name percent, and maybe I'll just call this line. So first thing is the sort field. The default is a sort by object ID or FID. And so if you don't choose anything, it'll automatically sort by object ID. Object ID in this case, so we'll hit OK, we'll come back to that in a second. If I look at my attribute table and I look at my object ID and I look at sort of my dates and times, they are indeed ascending with my object ID. So what I want to make sure happens is if I'm taking these points and I'm making lines out of them, then I want them to start from, 6:30 p.m. on May 30th and go to 7:30 p.m. on May 30th and not go to 7 a.m. on June 1st or something like that. So we have indeed verified that object ID is ordered such that it is in ascending date and time, which means that this sort of default of sorting by object ID, but we could also sort by, date, for example, or what if the date had all of the information that we wanted it to. This, if we just run this, and maybe I'll go ahead and just run a single points to line over here so you can see as a temp thing what happens when we run that single one with nothing in the, nothing in the line field. So let's just take a look at that while we're going. So the line field says that line segments basically are based on values in the line field. So here is all of our line, like our spaghetti, pile of spaghetti, right, from all of these things connecting. And if I open my attribute table, remember, again, this is one that didn't have anything in the line field. I noticed that it's just one giant long line segment, which is not necessarily ideal. Maybe I wanted to know, like by day or by, hour or whatever those units are, every hour or something like that, how far the animal moved. That's not going to do it. So that's where our choice of a line field becomes important. So I could do the line field based on date. That would work. There is one possible issue. And actually, I think that date should work totally fine because it has day, month, year, right? So this covers 3 different years, but it has day, month, year, so it should be okay. So let's just test that out as our new file that we're creating. And I'm going to open this attribute table. And now in this case, notice that I have, so put all of those, there were 3 or 4 different times associated with May 30th and May 31st and stuff. But in this case, now we have an estimate of distance traveled. So, this bear is doing like 10K regularly per day, according to the information that we have. Okay, so let's say that instead of wanting one giant line, right, instead or a line that's split up by day, you instead want the line that's split up based on all of these different points. There is a tool for that. There's a tool that's called split line at point, but I don't love that tool. It never seems to work for me. I prefer to split the line at vertices. And that's because all that this requires is the line file, because the line file was already created from those points. And so each of these points basically has created a vertex on the line, right? A place where the line direction shifts. So this is an easy way to split things up. And basically what this should do, split line, is create a whole bunch of different line segments for everywhere that you have a vertex on your giant line. Let's see if that worked. Okay, so this is good. So we have 4,949 line segments. Remember, for our original points, we had 4,950, right? Because there's one extra point because you've got them at the two ends of that line. That said, you could probably get away with using this as a join table to bring all of that attribute table back in here based on object ID. You would just lose, the last piece of information on here, basically. So if you wanted each of the dates and times and whatnot in this, join that table in, and that should give it to you. But I can at least see what my stats are in terms of, since these data were taken every hour or thereabouts, the mean distance traveled, it looks like, for my bear was not too far, actually, about half a kilometer per day, that's per hour, right? So about half a kilometer per segment in terms of 1 hour to the next. Although some of those went like 12 hours, so that's kind of an unfair comparison. Okay, cool. So now we have information about splitting stuff up. Let us get that into Model Builder, right? So we've got our points to line. And in this case, we just had the simple line field, right? So this is just going to create a single line output. And then I want to split that line at vertices. Oops, didn't want to do that, but put that in. And I want to make sure that my output name still gets my %name line. And where's the thing where I can clean this all up? Okay, so that'll clean it up a little bit. So now I have an iterator that's going to go through all of my bears, going to create points for those, going to output a line and split that line up so that I have all the different line segments, and also going to create the bounding geometry. And I think that was everything that we wanted to do. All right, so that took about 3 minutes, it looks like. So cross our fingers. Should have a bunch of files in here, any of which I can now grab my points for that animal, my split lines, and my convex hull, and continue to do whatever I would like to do with those data. All right, cool. So hopefully that gives you a sense of how to use the iterator and introduces you to a couple of new tools that you might want to be able to use converting your points into lines or points into polygons. So thank you much. I will see you in class.